Welcome to this video. Today in this video, we will learn about the surface area of a combination of solids. In the previous session, you have learned about the surface area of all solid figures such as cuboid, cube, cylinder, cone, sphere and hemisphere. If you are asked of the figures formed by the combination of these solid figures, can you find the curved surface area and the total surface area? Let's discuss about it. You all must be familiar with an ice cream cone because all children like it. Look at this ice cream cone carefully and identify the combination of figures that make the cone. Let's draw its shape. By looking at it, we can see that it is formed by combining two figures, a hemisphere and a cone, where the top part of the ice cream cone is a hemisphere and the bottom part is a cone. Now, if we have to put a paper cover on this ice cream cone, how much paper will we need? Correct. For this, we will have to find the curved surface area of the ice cream. Since we have to find the curved surface area of a figure that is formed by the combination of two or more figures, we will add the curved surface area of a hemisphere 2 pi r square and the curved surface area of a cone pi rl. We obtain the curved surface area of an ice cream cone as pi r within bracket 2r plus l. You can see that the paper used to pack the ice cream cone will be equal to the total curved surface area of the cone. Similarly, we can find the curved surface area and the total surface area of a figure formed by combining any two or more figures. Today in this video, we learned to find the surface area of a figure formed by the combination of solids. In the next video, we will see some interesting examples based on it. Welcome to this video. In the previous video, we learned about the surface area of a figure formed by the combination of solids. Today in this video, we will see some examples based on it. The general manager of a private limited company wants to put wallpaper on the outer walls of the company's warehouse, for which he contacts an engineer. We want to put wallpapers of dimension 50 cm square on the outer walls of the company's warehouse. So can you tell how many wallpapers will we need in total? Sure. But before that, can you tell me about the shape and the measurement of the warehouse? The company's warehouse is in the form of a combination of a cylinder and a cone, whose heights are 100 meters and 40 meters respectively, and the radius of the base of the both is 30 meters. Okay, I'll tell you in some time. The engineer first finds the total area of a wallpaper. What will the engineer have to do to find the total number of wallpapers? Good. For this, the total outer area of the warehouse is to be divided by the area of one wallpaper. Now, with the size and the measurement mentioned, the engineer makes a rough picture of the warehouse. He sees that the wallpaper will not be placed on the base of the warehouse and the part where the cone and the cylinder meet. So, in order to find the area of the wallpaper to be applied, he has to find the curved surface area of the cone and the cylinder. But to find the curved surface area of the cone, it is also necessary to know its slant height. Can you help the engineer find the slant height? Correct! The slant height can be found by substituting all the values in this formula. Now, to apply the wallpaper, let us quickly find out the total area of the outer walls of the warehouse, which is equal to the curved surface area of the cone and the cylinder in the warehouse. Can you give the formula for the surface area of the cone and the cylinder? Brilliant! Now let's solve by substituting all the values. From this, we get to know that the total area of the outer walls on which the wallpaper is to be applied is 23,550 square meters. Now we will divide this area by the area of a wallpaper so that we get the total number of wallpapers needed. The engineer immediately calls the general manager and tells that he will need a total of 94,200 wallpapers. With this example, we saw how our daily life problems based on solids can be solved. Welcome to this video. In the previous video, we solved an example based on the surface area of a combination of solids. Today in this video, we will see another example based on the area of a combination of solids. The length of a pencil is 23 centimeters and the radius is 3 centimeters and the height of the conical part of the pencil is 4 centimeters. Now can you find what will be the curved surface area of the pencil? To solve the question, pause the video and then match your answer. By looking at the pencil, we cannot tell which figure it is. But if we look at the figure carefully, we can say that its front part is a cone, middle part is a cylinder, and the lower part is a hemisphere. Where the height of the conical part of the pencil is 4 centimeters, radius is 3 centimeters, the length of the cylinder is 16 centimeters, and the radius of the hemisphere is 3 centimeters. Thus, we can say that this entire figure is made up of a combination of 3 figures. Now, if we sum the curved surface area of these 3 figures, then we will get the curved surface area of the pencil. We know the height and the radius of the cone, but for the surface area, we need to find the measurement of the slant height L of the cone. So, can you tell what will be the slant height of the cone? We can find the slant height of the cone with this formula, which we get as 5 centimeters. By substituting the value of the radius r, the height h, and the slant height L in this formula, and upon solving, the curved surface area of the figure is obtained as 405.42 square centimeters. So we can say that the curved surface area of the pencil is 405.42 square centimeters. In this video, we saw an example based on the area of solid shapes.
Welcome to this video. In the previous video, we have studied the surface areas of solids made of a combination of basic solids. Today, in this video, we will study the volume of solids made of a combination of basic solids. Can you tell what does volume and capacity mean? Well done! The space enclosed by an object is called the volume of that object. Capacity of an object is the volume of fluid or other object that can be filled in the interior of that object. Can you find out the volume of this pencil? Which method would you use to do this? On looking at this pencil carefully, we observe that this pencil is not a specific shape, but it is formed by a combination of some basic solid shapes. In your previous class, you have studied all these basic solid figures. Can you find out the volume of these solid shapes? Pause the video and write down the volume of these solid figures and then match your answer. Can you see that this pencil is made by the combination of a cone, a cylinder, and a hemisphere? Hence, to find the volume of this pencil, we have to add the volumes of these three basic figures. Let these be the measurements of this pencil. Let us now find out the volume of these figures one by one. Can you see that the diameter of this hemisphere is 2 centimeters? Then, what would be its radius? Correct! The radius of this hemisphere would be 1 centimeter. Also, we know that the value of pi is equal to 22 upon 7 or 3.14. On substituting the values of r and pi, and solving, we get volume of hemisphere is equal to 44 upon 21 cubic centimeters. Let's now find out the volume of this cylinder in the same manner. Here, the height of this cylinder is 14 centimeters. So, the value of h is equal to 14 centimeters. Can you tell what will be the radius of this cylinder? Here, you can see that the radius of these figures is same. That is, the radius of cylinder, cone, and hemisphere will be equal. And hence, the radius of all of these will be 1 centimeter. Now, for cylinder, on putting the values of pi, r, and h and solving, we get 44 cubic centimeters. Similarly, on solving for cone, we get 22 upon 7 cubic centimeters. Now, on adding the volumes of these figures, we can find out the volume of the pencil, which is 49.24 cubic centimeters. Come, let's see one more situation of combination of solids. Suppose we have this piece of wood, from which we have to take out a conical piece of radius 2 centimeters and height 10 centimeters. Can you find out the volume of the remaining piece of wood in the same way? Absolutely correct! We know that this new solid is also formed by a combination of two basic solids, cuboid and cone. But this time, these solids are not joined. So here, we will not find the sum of the volumes of these solids. Since here, one solid is taken out of the other solid, so here we subtract the volume of the smaller solid from the bigger solid. And this gives us the volume of the remaining piece of wood. In this way, today we learned to find the volume of the new solid formed by a combination of two or more solids, and of the solid formed when one solid is taken out of the other. In the next video, we will see some interesting examples based on this. Welcome to this video. Till now, we have learned to find the volume of the new solid formed by the combination of two or more solids, and of the solid formed when one solid is taken out of the other. Today, we will see how we can use this in our daily life. A conical vessel of radius 6 centimeters and height 8 centimeters is completely filled with water. A ball is thrown into the vessel which touches it and some water spills out of the vessel. Find out the volume of the water left in the vessel. Can you tell how we can find out the volume of the water left in the vessel? We know that the volume of the water left in the vessel is equal to the difference of the total volume of water in the vessel and the volume of the water spilled out of the vessel. Also, the total volume of the water in the vessel will be equal to the volume of the conical vessel, that is, the cone. And the volume of the water spilled out of the vessel will be equal to the volume of the ball, that is, the sphere. Because the ball spills out as much water as space it occupies. So we can say that the volume of water left in the vessel is equal to the difference of the volume of the conical vessel and that of the spherical ball. So now, we have to find out the volume of the cone and the sphere. From the figure, the values of the radius and height of the cone are known to us. But the value of the radius of the sphere is not known to us, which we have to find out. Can you tell how we can find out the radius of the sphere? Let the radius of sphere be S. Let's now draw a figure for given situation, in which we represent the cone by triangle and sphere by circle, where the values of OP and OM are equal since they are the radii of the same circle. Also, AM and AP will be equal. Can you tell why? Since AM and AP are the tangents to a circle from an external point A. You must remember that the tangent to a circle is perpendicular to its radius. Therefore, AP and OP and AM and OM will be mutually perpendicular. Now, by Pythagoras' theorem in triangle APC, we get AC equals to 10 centimeters. Also, From the figure, we can say that Cp is equal to the sum of CO and OP, from which we get CO equals to 8 minus S. In the same manner, from the figure we get MC equals to 4 centimeters. Now, using Pythagoras theorem in right angle triangle CMO, we get S equals to 3 centimeters, which is equal to the radius of the spherical ball. So, let's find the volume of cone and sphere and solve it further. To get the volume of the remaining water, which is equal to 188.57 cubic centimeters. Today, we saw how we can solve the problems related to the combination and separation of solids in our daily life.
Welcome to this video. So far, we have learned to find the volume of solids formed by combining two or more solids and separation of solids from one to another. Today, we will understand the conversion of a solid from one shape to another. Suresh has a box of sweets, which contains 3 kilos of barfi. If the weight of each piece of barfi is 20 grams, can you tell how many cubes of barfi will be there? We have studied such situations in our previous classes, based on which we can say that there will be 150 barfi pieces in the box. Now, let's look at this piece of wood. Its length is 15 centimeters, width is 6 centimeters, and height is 8 centimeters. Can you guess the volume of this piece of wood? Perfect! The volume of this piece will be 720 cubic centimeters. If this piece of wood is cut into 3 equal pieces like this, can you find the volume of each small piece? Well done! The volume of each small piece is 240 cubic centimeters. You can see here that the volume of each small piece is equal to 1/3 of the volume of the larger piece. Let us see some more examples. If we cut this piece of wood into 5 equal pieces this time, the volume of each piece will be 144 cubic centimeter, which is equal to 1/5 of the volume of the larger piece. So, we can say that if a solid is converted into a smaller solid of equal measure, then the product of volume of the small solids and the total number of small solids is equal to the volume of the larger solid. Is it true for the entire surface area of solids? If we take this piece of wood and if we calculate the surface area of these 5 pieces made from it, you can see that this statement is false for the surface area of solids. Is it applicable only to solids of similar shape? No. This is true for all solids. Let's look at an example. If we melt this iron cylinder and make 24 cones of height 9 centimeters and radius 7 centimeters and then calculate their volumes, we will realize that this statement proves to be true even in this case. Today, in this video, we learned that on converting a large solid into small solids, volume of large solid is equal to volume of small solid multiplied by the total number of solids. Welcome to this video. So far, we have learned that the total volume of solid or solids formed after converting a solid to another solid or solids is equal to the volume of the first solid. Today, we will see some interesting examples based on this. Shyam works in an iron factory where iron objects of different shapes are made. One day, Shyam tries to melt an iron sphere of radius 8 centimeters and make some cones with a height of 8 centimeters and radius of 4 centimeters. Find the number of cones made by Shyam. Pause the video and try yourself. Then match your answer. From the question, let us consider r as the radius of the sphere and let r be the radius of the new cones formed. Height is h. So now, can you calculate the number of cones made by Shyam? We learned in the previous video that if a solid is converted into smaller solids of equal measure, the product of the volume of the smaller solids thus formed and the total number of smaller solids is equal to the volume of the larger solid. Here, we have big solid sphere and small solid cones. Therefore, we can also write this statement as follows. We know that the volume of sphere and cone can be determined by these formulas. Substituting all values, we get 16. So, Shyam makes 16 cones in this way. Let's look at another example. This cube is made of model-making clay. Sanjana transformed this solid into another solid with a radius of 7 centimeters. Can you calculate the height of this solid? Let the total height of this new solid made by Sanjana be capital H. From the picture, we can see that the new solid is made of a hemisphere and a cylinder. We can also see that the radii of these two solids are equal, that is, 7 centimeters. For a hemisphere, its radius will be its height. So, what should be the height of the cylinder? Since the total height of the solid is h and the height of the hemispherical part is 7 centimeters, therefore, the height of the cylindrical part will be h minus 7. Can you guess the next step now? We know that while converting one solid into another solid, the volume of both solids remains the same. So, the volume of the cube here will be equal to the sum of the volumes of the hemisphere and the cylinder, On substituting all values and solving them, we get H equal to 10.98. So, the total height of the new solid will be 10.98 centimeters. Today we saw examples based on conversion of solids. In the next video, we will see some more such interesting examples. Welcome to this video. In the previous video, we saw some examples based on conversion of solids. Today, we will see some more examples. Ram irrigates a rectangular field with a pipe of 7 cm internal diameter. The water flowing out of the pipe flows at the speed of 72 cm per second. If 10 centimeters of vertically flowing water is required for irrigation and it takes 30 minutes to irrigate the field, so what should be the area of Ram's field? Pause the video to try yourself and then check your answer. We know that the pipe fills the field in 30 minutes. So, we can say that the volume of water coming out of the pipe in 30 minutes is equal to the volume of water filled in the field in 30 minutes. Can you calculate the volume of water coming out of the pipe in 30 minutes? We know that the pipe is shaped like a cylinder whose internal diameter is given to us, that is 7 centimeters. We can calculate the radius by dividing the diameter by 2, that is 7 divided by 2. We will also need its length to find the volume of water coming out of the pipe. Let's assume for a while that the water is flowing out of a never-ending pipe. The question states that the flow of water is 72 centimeters per second. That is, water covers a distance of 72 centimeters in a second. So, the distance covered by water in 30 minutes will be 72 multiplied by 60 multiplied by 30 centimeters. Now, if we assume that the water is static for some time, can you guess the volume of this water? Well done. We can do this with the help of this formula, where R is the radius of the pipe and H represents the distance travelled by water in 30 minutes. Which gives us the volume of water coming out of the pipe in 30 minutes. Now, after watering the field, the height of the water becomes 10 centimeters. We know that the volume of water coming into the field is equal to the volume of water released from the pipe, and we also know that the volume of water filled in the field is equal to the product of the area of the field and the height of water. So now, we have to find the area of the field. We know that the height of the water is 10 centimeters as given in the question, and we have already found the volume of the water coming out of the pipe. Replacing all the values in the formula and solving further, we get the area of the field. So, the area of Ram's field is 49.896 square meters. Hopefully, you have understood how to convert solids from one shape to another with the help of this example and are able to use it in our daily life.
Welcome all of you to this video. So far, we have studied about the total surface area and the volume of new solids formed by the association and dissociation of basic solids. Moving forward with this concept, today we will learn about frustum of a solid cone. Dear children, let's see a new shape of this solid family, which looks like a cone but is not a cone by shape. It's a part of cone. We call it frustum of a cone. If cone is cut horizontally, it gives one frustum of a cone. Today, we will know this. When pointed area of cone is removed, the rest is called frustum of cone. Frustum is a Latin word which means sliced piece. Just as you are familiar with all the solid shapes in your daily life, in the same way, you have seen the frustum of cone around you, such as this glass of water, bucket, bowl, cup, flower pot, table lamp, shape formed by light emanating from table lamp, etc. Let us now observe it. To understand the frustum of a cone, let's take a cone whose height is capital H, capital L is the slant height, and capital R is the radius. If we cut this cone parallel to its base, like this, we get two pieces of the cone. So can you tell what are these two pieces? Absolutely correct. The top piece is a cone and the bottom piece is the frustum of the given cone, which we are going to discuss today. You can see that the frustum has two circular ends. Its lower end is called the base of the shape. Can you tell the radius of this base? Absolutely correct, because it is the lower part of this cone. Therefore, its radius will be the same as the radius of the cone, which is capital R. If we represent the subtracted radius of the upper end as R, the height of the frustum as small h, the slant height as small l, then we can find out slant height, total surface area, curved surface area, and volume of the frustum with the help of their formulas. Can the radius of both ends of the frustum of a cone be equal? Give it a thought. Today we learned about the meaning of frustum of a cone. In the next video, we will solve the problems faced in our daily life based on the frustum of a cone. Welcome all of you to this video. So far, we have learned what is the meaning of frustum, what is meant by frustum of a cone. Today, we will solve the problems faced in our daily lives based on frustum of a cone. Rita wants to make a paper cap in the shape of a frustum of a cone, the height of which is 14 cm and the radii of the circular ends are 6 cm and 8 cm. If the cap is open from the side with a bigger circle, then tell Rita would be needing paper of how many square centimeters to make the cap. Pause the video to try yourself and then match your answer. Can you tell how we can find the size of the paper? Absolutely correct. For this, we have to find the surface area of the cap. Because cap is open from the bottom and closed at the top, so we will not find the total surface area. Rather, we will add the area of the closed end to the curved surface area. The area of the open end will be subtracted from the entire surface area. We will solve this question in the first way, and the second way will be left for you to try. Now we mark the given measurements as follows. In the previous video, we learned that the curved surface area of the frustum of the cone can be derived from this formula. Since the closed end of the cap is circular, here we will use the formula for the area of the circle. From the formula, you can see that to find the curved surface area of the cap, we need its slant height, which is not given in the question. Now, how can you find the slant height? Well done. We can find the value of the slant height from this formula. Replacing all values, on solving, we get the value of L, that is, slant height 10√2 centimeters. Now replace all values in these formulas. On further solving, we get 733.48. So Rita would need 733.48 square centimeters of paper to make a hat. Let's see another example. A bucket which is 15 centimeter deep and the radius of the upper and the lower portion of which is 20 centimeters and 10 centimeters respectively, then how much water will it hold? From the question, we know that the radius of the top of the bucket is 20 centimeters and that of the bottom is 10 centimeters and with the depth 15 centimeters. Also in this question, the value of pi is given as 3.14. So, can you tell how much water can be filled in this bucket? For this, we have to determine the capacity of the bucket, for which the formula of volume of frustum of the cone will be used. Solving by substituting all the values, the capacity of the bucket is found as 10,990 cubic centimeters. Also, we know that 1000 cubic centimeter is 1 liter. Therefore, 10.99 liter or about 11 liters of water can be filled in the bucket. Today we learned to solve the problems faced in daily life based on the frustum of the cone.